Welcome to another Synchronous technology video. In this short presentation, I want to show you how we can convert a traditional history-based solid edge model into a fully synchronous model. Here we have a history-based model of a pump housing. We can see that it's history-based by playing back the features that were used to construct the part. Remember, the way a part is constructed determines how you can edit the part later on. This can sometimes be restrictive when it comes to modifying a traditional model. Let's take a look at how easy the convert process is. The convert function can be found under the application menu. Here we simply select the files we want to convert. If we had selected an assembly, all the components in the assembly would be selected for conversion at the same time. It's important to point out that the conversion process replaces the existing files with the new ones. For this reason, it's important that we have a backup of our existing data in case we want to revert back to a traditional model. The conversion is very quick and is actioned once you hit the process button. Let's now open up the pump housing again and take a look at the file. We can see by the title bar and the icon layout that this is now a synchronous model. Looking in the Pathfinder, we can see that all the traditional features have been mapped over as face sets, and where appropriate we have procedural features such as holes. Any model or profile dimensions have been converted to PMI dimensions. We'll see some of these in action in a moment. And finally, any profiles used in the creation of the traditional model will be evident in the Use Sketch Collector. Since this is now a synchronous model, we can simply grab geometry and start moving it around. We can also use the PMI dimensions to adjust things as required. Notice how our live rules is ensuring the model stays intact here. Let's increase the length of the part to make room for another port. Grabbing the geometry and pulling with the steering wheel achieves this easily. Whilst we're here, we'll also modify the size of the round simply by selecting its Edit Definition handle and changing the value. To create that extra port, we'll simply select the existing one and use the steering wheel. Geometry reuse in a synchronous model is extremely easy and efficient. Rotating the new port round by 90 degrees is also no problem with the steering wheel. The holes on the mounting flange have been converted as procedural features. This means we can very easily modify their parameters using the Edit Definition handle. Let's also take the end of the part and stretch it out a little so that we have some room to modify the thickness of the mounting flange. Again, simply window selecting the geometry and manipulating it with the steering wheel is all that is required. Next, we'll place some PMI dimensions onto the model. We'll be able to use these PMI dimensions to directly drive the geometry. We can see that as we change the dimension for the flange width, we've got complete control over the direction of the dimension. PMI dimensions can also be locked at their current value. Now when we make any changes, the sizes of the lock dimensions will be maintained. We can see this as we adjust the flange width again, firstly with its dimension, and then by adjusting its face with the steering wheel. As we can see, converting an existing history-based part into a synchronous model is extremely easy and provides us with the outstanding geometry creation and editing capabilities that this technology offers.